Hi, so this is the third video for Environmental Systems 2 dealing with the NAAB compliance portfolio pages that we are delivering as part of our final portfolio. This is the sample page I made for the sample layout I made for this page. We're dealing now with the measurable environmental impacts of your design decisions. We've decided to make that dealing with daylighting and electric lighting. So before I talk about how to create a page like this, let's just remind ourselves or review the simulation workflow a little bit. Unlike with thermal analysis in Climate Studio, where we could not use non-planar surfaces, we can use non-planar surfaces or surfaces that curve out a plane in daylighting. So I've done so here. I've got a volume, and all we need then is a volume that's defining the outside surfaces of a building, and then a single glazed surface to represent glazing or fenestration that's either applied coplanar to the exterior surfaces of the building or the interior. They can be interior also, or we could also actually punch this the surface between these two lines out of the volume and apply the glazing to that hole. The reason I bring that up is because occasionally I have trouble getting this to work with the applied surfaces. Because basically what we're saying is that the model sees this as a solid or a solid surface, and that we're applying a piece of another surface on top of it and just saying, hey, this is glass. We're defining that here, and the model goes, oh, okay, I get it. I'm going to see through the rest of the surface. Sometimes it doesn't work, and so you have to punch a hole. That's very rare. You may not come across it, but just letting you know that that's another option. Okay, so now I've got my surface and my exterior surface and my glazing. The one other thing I need, and that's all you need, other than shading, is a work surface. Here I've got a floor that I've created in here. I offset it a little bit from the edges, and then I made a work surface out of it, which I'm in the daylight availability workflow. I'll say why in a minute, why we're using the daylight availability. So just realize there's a reason for it. I'm going to edit this work surface that I made just so we can remind ourselves. I think 5 feet sensor spacing is good. 2.5 feet off the ground, 30 inches is sort of a standard. But basically, you should put this wherever, if you're in a gym, it would be on the ground. It's wherever the person who is going to be seeing the light is going to experience it from. So if it's at a desk height, it'd be 30 inches or so. If you're in a gym, it's going to be at the ground. This inset is just saying how far the first sensor is off the edge of the work surface. Anyway, so we've got that. Let's run a sample and see what we get. And I've got my range down here set. I can actually set this to 0 at 0 to 5,000. You always want to have a range, and this is really important. You don't let's say I run 10 simulations and I want to show them all and they're related to one another, then I want to create one range. But I can change this at any point. So I can say, oh wait, let me try what would happen if it was 3,000. It doesn't change the data. And so the point is I want to find a range of colors that will work for all of my outputs so that they relate to one another. You can change this as much as you want before you're actually comparing things, but once you're comparing, you want it to be the same range. And you need to always show that range. So for example, I just put mine down here. Maybe that's not the best place, but we're measuring, we're quantifying. We need to understand what these colors are, what they mean. They can't just be colors. So they need to be associated with numbers. Okay, so I ran that simulation. We've got actually a huge amount of light, 10,000. Okay, here's the other concept: is that when you're doing daylighting, you have to have a goal. When we're designing for daylight, and so my goal in this little exercise is going to be to create a consistent amount of light throughout the space. I'm not going to worry about it with this particular. This is just an example, but in the model I've made, it's a gym, and I want it to be a consistent amount of light throughout. So I need to have a target lux that I'm searching for, or that I'm shooting for. You can look that up online for different surfaces. We've provided that information in different assignments. if you're just in a pinch, 3 to 500 is a good like for a lot of different types of activities. That's a good range to choose. But you should find specific, and also if you're doing more than one space, you would have different target luxes for the different spaces. Okay, so anyway, I'm at a really high 4300 would not be something you would use in a place where you're trying to work probably. Another point, but this is what I was saying why we're running this daylight availability workflow. Let me just go ahead and give this a quick name so I can save it. Is because so we have the option here to either do to do a lot of things, but we could do a daylight availability or we can do a point in time, and we will use a point in time for something specific. But I've been seeing a lot of people using point in time all the time. That doesn't make sense because the daylight availability is both an annual average, and you can also do a specific day and hour, and that's point in time. So with this one simulation, we have access to both point in time for any day and hour of the year, and we have an annual average. So that makes more sense to use than a point in time. Okay, now let's say I want to reduce the amount of light coming through this glazing here. What can I do? Well, the most obvious thing to do is change the glazing. So I'm going to do that. I had already chosen for this a very high visible transmittance glazing, this Starfire 91% VLT. That's visible light transmittance, so it's 90% of the visible light's coming through the glass. U value and solar heat gain coefficient or other terms, how many panes we have, double, triple, none of that matters in terms of daylighting. All that matters is visible transmittance. So if you tell me I got a triple pane piece of glass, why isn't it reducing my the amount of light coming in? It's because you're not understanding the basic metric here, which is visible transmittance. Okay, so look for, if you're trying to adjust your glazing, you're adjusting the visible transmittance. So I'm going to find something much lower. And if you click on these titles, it will arrange that, it'll go in chronological order for that variable. I'll just pick it's something that has 21%. That's very low. You probably wouldn't be able to see very well through it. But to illustrate what we're talking about, it's a good thing to do. So if I run this, now I have a much lower, all I did was change the glazing. I'll call this 2. I should have a more descriptive name, but I'm just giving examples here. So I went from an average of 4,300 to an average of 1,000. I've also got a kind of more even distribution, it seems like. And again, I could change this range if I wanted to. Okay, the other thing I want to quickly demonstrate is applying tubular skylights and electric lighting, because I think that's sometimes been confusing for some people. So if I want to add more light in this space and I don't want to add more side light, I can add top light inside this lead daylight availability simulation. So that's this tab here. If I want to add a skylight, these are actually commercial unit skylights. There's a lot of different. If you haven't used these, you have a visible transmittance. That's why you need to understand that. That's going to let in 50% of the visible light. The diffuser size is like about 3/4 of a foot. I'm going to come down here and pick something much larger. So I get a visible transmittance of 0.92 and a 2.5 foot diffuser. That's going to be much bigger. I'm going to select that and place it in my model. And I think, I'm not sure where it's going to snap. Doesn't really matter. Okay, let me go to a side view. So now I've got my my skylight in place, but it's not placed where I need it. First, I need to pull this. This is a little bit weird. You don't need to. This is actually supposed to be at the roof. You can have it a little bit above, and so the way this works, this is like a little parabolic. Let me show you. This isn't completely placed yet, but this is a little parabolic dome. Let me turn on a different color here. All right. So we can see it better. I'm going to turn off my grid. So you can see this is this plastic dome that's going to collect light from all different directions. The light is then transferred through a reflective tube that can be curved. Like, let me show you again. If we go back in here, you see these ones at the top. There's different models that can actually curve through that can be moved through at an angle. And this is the light's reflecting through this tube the whole way. And then at the bottom, there is basically a light fixture. It's a diffuser. And so that needs to be set below your ceiling or at your ceiling. This needs to be set at the roof or a little bit above it. So since I only have a surface here, that will work. So let me move it into a sensible place. You don't want to edit these. Oh, come on. I guess it's going to be easier from the angle. Let's see what that looks like. That's good enough. Just trying to get it somewhere where it'll make it have an effect. Okay, so, and I could make an array of these. If you start looking around, these are everywhere. And that's a cool thing about this simulation is these are actual products that you can specify. Okay, so I've got that, I think, in the right place. Let me run my simulation. And again, I'm doing a daylight availability, so it's during the day. It has to be during the day. And I can see now that, yeah, 3:30 before, and now 797. That was quite a bit different. So if I change this range at this point, I would see more of a difference. But we can see it by mousing over. And realize, too, you can turn on these variables so that I can see the values all the time. So it's a big difference from that one skylight being placed, right? And so obviously a skylight has to be run during the day, right? If I want to add lighting, electric lighting, I have to add that in a point time illuminance model. So that's really the reason why these are still here, in my opinion. So I've gone to the point in time. I'm going to add an electric light. There's tons of them I can choose from. Doesn't really matter. Place it in Rhino. Don't know where it went. I think it was there, so I'm not sure what happened. Oh, I think it is there. It's just tiny. Yeah, okay. The reason why is that not showing up with? Let's see. All right, you have to be in wireframe to see the pattern of the light. If we go back and look at this, if I edit this light, we can see this pattern here. I can't teach the whole class right now, but so these are different patterns of how the light comes out of the fixture. And so if we're in wireframe, we can see that pattern in the model. And then again, I can move this wherever. I'm not really going to. I can move this down. Maybe I'll do that just so that's too far. So yeah, you wouldn't have it. Well, you might. Well, actually, not as low as I thought. I don't think it's going to have much of an effect, that single light, but let's just run it so we can see. Oh, and of course, I needed this to be at night. Sometimes if I put it at 2400, it doesn't work at midnight. Anyway, you should have already done these. You can see that it has an effect. Oh, right, because now the skylight's having no effect, so then it's only this one light that's bringing any light into the building, and so we can see that it has an effect. Okay, so that's the basic workflow for doing this. So let's look at how to deliver a page like I was showing. This page here. First, let me just introduce the project really quickly. This is the site. This was the site you guys used for your gem charrette earlier in the semester. I'm using the same gem project that I used on the previous, in the thermal analysis. Gym, outdoor court. This is the layout of the building. And so my daylighting strategy here is that, so this is the south side, is that I want to get, I'm just going to be talking about, I'm just going to be designing for the gym. Remember that just like with the thermal analysis page, or I'm sorry, just like the uh, HVAC page, we only need to focus on one part of the building. So you don't need to design everything, but you do need to have a clear goal. So my goal is very simple. I just want to have a consistent lux value of around 500 on the floor, both at the spectators, which is back here, and on the court. So I ran several simulations. Let's go back to, that's fine. Actually, let's go ahead. Because I have to change something. Um, yeah, the first point to make is that, so I ran some simulations with everything. Uh, so that, like there's even there's a rationale for looking at the outside. You don't have to. I personally don't like having the values on a lot of times, so it definitely makes things clearer. I think the thousands maybe. I'm not sure if it's the right um, layout. Oh, but let's just so we understand. This would all be done in your elsewhere in your project, but uh, let me turn this off. Okay, so I have in the gym I have glazing on the north and a high southern glazing. The rest of the project it wraps around, and there's glazing facing the court. But we're just talking about then these two pieces of large expanses of glass on the south and north side of the gym. There is some glazing on the interior that I'm ignoring. So we started off with um, a huge amount of light from. Let's see. Looks like I had a. This is without the context on. Then I brought the buildings in, then the trees, and then added court shading. So the point is that you can very quickly, as you're running these simulations, see the effects of what you're choosing. But I'm going to go just to the gym now and just focus on that. And the way I'm changing that is by if you're in where you're adding areas. Actually, it's interesting. For some reason, my work surfaces are not here anymore, so I'm just going to re-add them. I'm not running simulations right now, but it's just this is always it's just good to kind of. I think it helps maybe just to be going through this as I'm showing you things. So my work surfaces are on this layer here, and then you can see them. They show up right when I turn this off and back on. So when I re-add them, it should remember them. So if I'm going to select all this, I mean the model should remember them. Select objects, add. Okay, yeah, and see there's the. This happens sometimes with Climate Studio. I don't know what's going on. I obviously just opened this model, and it just said you don't have any surfaces. Then you add them, and it remembers them and their names and everything. Okay, so then all I was doing is I turned off everything except for just the gem surface, and that's what I'm using when I'm running these simulations now. So this is the gym with no awning, and what we have then is light coming in only through those two pieces of glass. And so what's happening is we're getting a very uneven, huge. It's way overlit here, and then a swath where it's not lit enough. And so that's what I'm showing here. And I think it's important when you're doing this to highlight some numbers. So I basically am saying I've got a target lux of 500. I'm not getting there with my initial baseline. Way too high in some places and too low in others. And then I am going to try the following strategies. I'm going to add a light shelf and skylights and see what happens. And I ran a couple of different versions of these. I tried different lengths of the skylight. Let's see, here it is on. And I added these skylights. And when I did that, I got this result. I think, or actually, no, I think I went through. No, this is the final one. Was this result? So I won't go through all these different versions, but like here's a 5-foot light shelf. Here's trying a different visible transmittance glass. And so now I've got something that's I'm kind of around my 500 goal. Down here at the bottom on the north side, it's pretty high, but this is just heading out. There's nobody sitting down here or playing down here. The court, if we turn this off and see the court, the court's here. So it's just a little bit bright down right at the very edge, but that's not a problem. And also, this is north-facing glass, so it's not going to be glary. Oops, what was that? So what I'm saying now, if I go back to my, is that I started here, I applied these strategies, and then I got to here, and I feel like that's a successful daylighting design. The next step, and again, you could maybe even stop there. I don't know. That's what we're looking for: measurable environmental impacts of design. That does it. I went much further, so I'll continue telling you what I did, and you could follow suit or find some other way of doing this if you want. These are just suggestions. So then here's the deal, though. This is the average, the annual average, right? If I go to a specific day and time and start flipping through, that's very different than here, right? There's clouds involved in the model. Of course, different times are going to be different. So there's a lot of variance. So the next level of design would be to say, okay, what am I going to do in these times when the daylighting is insufficient and I got a game in here or a match? Well, I'm going to need to add some electric lighting, and I'm going to need it to work with my daylighting. So to do that, I need to change to a point-in-time illuminance model. So that's what I did here. Remember that it's just a different workflow here. And the difference is you have to pick a sky model that's just a mathematical model of how the sky is reflecting light. Doesn't really matter which one you pick; they'll be different, but it's as long as you keep it consistent. And so what I did is I picked a day here, January 8th, 10:30 in the morning. You pick whatever, pick one that's not getting you what you want. And I ran the simulation at that time. And I see that I get a very low light here. It's not going to be enough for someone to play a game, and it's not so important at the spectators. But this is more like a corridor here. And so then I added some electric lights, and let me turn those on. Oop, not that. Let's see if I can. I'll just show you it to be more quick about it. This is the image I took, and so I added, these skylights were already there. I put the lights at the level of the light shelf, and I added these 5 rows. This is a lot of lights, but that's actually, I think, these are, I think, 7 feet apart. This is probably 15 feet, so they're pretty well spaced. And then I left off a row at the end because if you look at my results here, is that this is the place that I don't really need light at this point in the time, during the day, because there's light coming in from that window all the time. So when I ran that simulation with the lights and the skylights, I got this at that same time, which is much more in line with my goals. So that's then this result. So I'm saying these are the 2 changes. I pull out a number and show it. I show a graphic of what I put in place. I'll talk about these over here in a minute. So what have I done so far? I've said, okay, my daylighting, I've got good daylighting design to, at least on average in the year, get the target lux I'm looking for. For times when I don't have enough light because there's clouds or it's a different, it's early in the morning, I'm supplementing with electric lighting, and I'm showing that that's working. My next step then was to say, okay, well, now I need to have lights on at night and make sure that I've got enough light to do the same activities at night that I would do during the day. So what I did was I added this row of lights. I don't know if I used the same lights. To tell you the truth, I might have switched it between these two. You should use the same, but since they're dimmable, you wouldn't really have to, because it's conceptual. I'm just showing that I have a pretty even amount of light around, definitely around the playing area, and any place that anybody would actually be standing or doing anything. I've got a very consistent amount of light that's around 500 lux, which was my target. So that worked. Let me just see if there's anything I should show you the model on that. No, just oh, and then yeah. So remember that all you're doing here is you're doing a point. Oh, that's the one thing I should say. Remember that. So I'm using the same day. I just moved it to night and ran it. And that meant the skylights didn't matter. I can turn them off if I want to, but they're not going to have an effect at night. Um, oh, and the reason we're not seeing again the pattern of light coming off is because we're not in wireframe mode. So there's my actual lights. Okay. Then what else did I do here? There's one thing that's a little bit fluff, and the other that's important, and I think you should do, and it's very easy. Um, I just did a radiance render here, and all I was doing was just saying, we don't have that if we just would have done a typical curtain wall that people would often do, there's a fair amount of light pollution that's happening in the neighborhood. And if with my actual design, I don't have as much light pollution. If this is standing behind the trees at the sidewalk. Um, the way I actually use radiance renders is part of a glare study. We're not really doing that. In my section, some students have learned that and are applying that, and I think that's great. And if you're doing that, then there's a different way that I've showed you to use a radiance render. So this is optional. This is a radiance render, if you don't know, is just another workflow in Climate Studio. You set, like so right now the simulation window is the window in Rhino, but I can also set it to something else. Um, so anyway, it's just something to play around with if you want to, and then you run it and you can play around with the settings and see if you get an image that makes sense in terms of the goals that I was just talking about. So what's this final thing over here? So remember, we're trying to quantify measurable environmental outputs. And we have a situation where we have day lighting and electric lighting. So a question we could ask would be, are we saving energy by using electric lights? And that's easy to determine. I mean, it's not completely accurate by any means, but I think it's a good example. And it's easy to do. So let me show you how we do it. If we're back at now we're in page, whatever, another page that you should have already done. At least that's the order I would do it in. I would do my thermal analysis first. This was my optimized thermal analysis. Let me show you that page. So I optimized from, started at 468 site EUI, got down to 98 with my New York City code, and then I did some more optimization and got down to 51. And when I'm at 51, here's my lighting. It's the yellow swath in here. So is there a way I can turn off this lighting when I have enough day lighting that I don't need it? And there is in the model. If you go into, you need to have your simulation set up to the same way it was for however you optimize. So let's say this is my optimization settings here. If I go into my zones, go into the space setting template, the space use setting template, and in that template there is in the lighting section we have a dimming type. And so what are we saying here? We're saying that we also probably should have a schedule here, right? I mean, that would be another way. This is basically saying we're having the lights on all the time. That's pretty stupid. So we would save a lot of energy if we create a schedule, and I'm pretty sure I did in the versions that I had. I mean, the later versions of my optimization. Yeah, this is the baseline, because I also have the 60 illuminance target. I know for the NYC it's 45 or something like that. Anyway, the point is we're saying, okay, I've got lights that are have a 1.5 watt per square foot lighting power density. That means they're using 1.5 watts for every square foot of space. And I have an illuminance target that I'm trying to hit with that lighting. But this dimming type, if you look it up in the Climate Studio help website, this is photocell triggered. So in other words, when there's sun, it's going to dim. And so if I put this on stepped or continuous, so I think will give you the best results, or a little bit better, and I run it, then I will get I should get a lower site EUI, because then whenever there's enough daylight in the space, then my electric lighting will be dimmed or turned off. And so we see that I do, in fact, get quite a considerable drop. And you can see the lights, the band for the lights dropping down between the two. And what I did was 43 to 51. This is why you want to do it at the once you've optimized, because that's going to be a constant, whatever that 8. Let's see, what was 51? Yeah, so that's uh, yeah, 8 kBTUs per square foot that we're reducing our site EUI by this dimming. If we were looking at, you know, the crappy 1960 building, 468, that wouldn't have much of an effect. But here it's going to have a pretty big effect. And if we look at that on the page, 43 divided by 51 is 16%. So we reduced the power requirement, the site EUI, the energy use of the building, 16% theoretically by adding lighting. Now, again, if just truth be told, or full disclosure, this was for the entire project, not just the gym. But I think it's still, it's I think that would be, it might change a little bit, but I think that would be accurate. And it's a really good metric to use for these purposes. Okay, so in summary, you don't have to necessarily do something this complex, though I hope you do. But the main point is you have to quantify, we have to be measurable, and the measurements have to have meaning, and a good way to show meaning is to start someplace, have a strategy to change it. I mean, have a goal, start someplace that isn't reaching the goal, have some strategies that you try, and then show that you reached the goal that you set. All right? Let me know if you have any questions.